Are you tired of waiting ages for your files to copy? If you're dealing with hundreds of thousands of files, you know how frustrating that can be. Today, we're going to explore how to speed up file copying in Python using multiprocess and multithreading. I completely understand your pain. Copying large amounts of data can feel like watching paint dry. You're not alone in this struggle, and many people face similar challenges when working with large file transfers. Let's dive into the specific question at hand. One user asked, how can I optimize my file copying process in Python, especially when dealing with over 100,000 files? They mentioned using Shootle for sequential copying and noticed that their hardware resources are barely tapped out. Sound familiar? Let's find a solution together. So what's the issue here? When copying files sequentially, you're not taking full advantage of your system's capabilities. With 40 cores and 64 gigabytes of RAM, you have the potential to significantly speed up the process using multi-threading or multiprocessing. Stay tuned because at the end of this video, I'll share a crucial tip that can boost your file copying speeds even further. To begin optimizing file copying in Python, the user should first import the necessary libraries. This includes the multiprocessing library for parallel processing and the Shootle library for file operations. Next, the user should define a function that will handle the file copying. This function will take a source file path and a destination path as arguments and use Shootle to copy the file. Now, the user needs to create a list of all the files to be copied. This can be done using os.listdir to gather all file paths from the source directory. After that, the user should set up a multiprocessing pool. This allows multiple file copy operations to run simultaneously, significantly speeding up the process. Finally, the user can run the script to start the file copying process. They should monitor the performance and adjust the number of processes based on their system's capabilities. Fun fact, did you know that the fastest file transfer speeds can reach up to 10 gigabits per second? That's like copying an entire movie in just seconds. Now let's look at the answers provided by other users. An alternative approach suggested by another user is to use a thread pool for file copying. This method allows you to copy multiple files simultaneously, which can significantly speed up the process. Let's take a look at an answer from another user. An alternative approach to speed up file copying is to use gevent in Python. First, create a CSV file listing all the files to be copied. Then, divide this list into chunks based on the number of processor cores available. Each chunk is processed by separate threads, which read the file names and copy them sequentially. To implement this, save the provided code as filecopier.py. Then, run the script from the terminal with your CSV file as an argument. This method can significantly enhance your file copying speed. Now, let's see a response from a different user. One user suggests using the thread pool executor from the concurrent.futures module to handle file copying more efficiently. This approach helps avoid the too many open files error that can occur with daemon threads. That wraps up that answer. Let's move on to another one. An alternative solution involves using a multi-threaded approach with Python's thread pool. This method simplifies the process of copying a directory tree by leveraging multiple threads to speed up file copying. Here's the tip I promised. Regularly monitor your system's performance and adjust your copying methods based on the type of files and your network conditions. This can lead to significant improvements over time. And there you have it. With these techniques, you should see a noticeable increase in your file copying speeds. Remember, optimizing your process can save you a lot of time. If you found this video helpful, please subscribe for more tips and tricks.